Toyota's insane new 750-mile battery shocks the entire industry. Toyota is making waves again, and this time they're diving headfirst into the electric vehicle game with some serious gusto. After their initial foray with the bZ4X left a bit to be desired, Toyota's gone back to the drawing board and came out swinging with something truly groundbreaking. And it's none other than Toyota's latest innovation, the mind-blowing 750-mile battery. And yeah, you heard that right, 750 miles on a single charge. It's the kind of leap of faith forward that's got the whole industry sitting up and taking notice. So, join us as we dive into what makes Toyota's latest creation so jaw-droppingly impressive. Get ready to be shocked in the best possible way. Let's break it down. This new battery type that's causing all the buzz, it's called Toyota's all-new solid-state battery. Now, solid-state batteries aren't exactly new kids on the block. They've been around since way back in the 1830s. But here's the kicker. Despite being around for ages, the technology behind them hasn't really been up to snuff. So most ideas never made it past the drawing board. But Toyota, being the trailblazers that they are, saw the potential. They said, hey, these solid-state batteries, they're onto something. So they rolled up their sleeves and got to work, pouring their resources into making solid-state batteries a reality. And here's where it gets interesting. While most solid-state batteries ditch the lithium, Toyota's version still keeps it in the mix. So what sets these bad boys apart from your run-of-the-mill lithium-ion batteries? Well, it all boils down to a pretty significant shift in how they handle their electrolytes, the stuff that lets those lithium ions do their thing. You see, traditional lithium-ion batteries rely on liquid or gel-like electrolytes to shuttle those ions between the anode and cathode. And while this setup is great for the ease of maintenance, you pretty much just set it and forget it, it does come with some risks. Namely, if these batteries take a hit, they can go from zero to meltdown real quick. Enter solid-state batteries, and as the name suggests, they swap out those liquid electrolytes for solid ones, usually made from either polymers or ceramics. This switcheroo not only beefs up safety by a mile, no more worrying about fiery explosions that can't be put out, but also allows for a much smoother flow of lithium ions. Now, you might be thinking, okay, cool, so what's the big deal? Well, the difference is night and day. While the basic structure of solid-state batteries might seem pretty similar to lithium-ion ones, their real-world performance is in a league of its own. And here's the kicker: safety. With traditional lithium-ion batteries, any little mishap could turn into a fiery disaster, but with solid-state ones, you could breathe a whole lot easier. They're built to take a beating without breaking a sweat, making them a game changer for everything from smartphones to, well, you guessed it, electric vehicles. So when they come to safety, solid-state batteries are miles ahead of the competition. But along with beefing up safety, solid-state batteries bring a whole new slew of other benefits to the table. Think of longer driving ranges, faster charging times, and increased durability. Basically, they make electric vehicles way more practical for everyday use. And they're not just safer, they're way more compact and lighter than the ones you'll find in your typical lithium-ion battery. So what does all this mean for you? Well, it means that the batteries themselves take up way less space. That's right, say goodbye to bulky battery packs hogging up your car's interior. With solid-state batteries, there's more room to stretch out and relax inside your ride, making for a comfier journey for you and your passengers. Plus, since these batteries are lighter, they're like a little weight loss program for your car, and shredding those extra pounds does wonders for both efficiency and driving dynamics. Speaking of efficiency, let's dive into just how impressive these solid-state batteries really are. They boast a significantly higher energy density compared to your typical lithium-ion batteries. So what does that mean in plain English? Well, it means they can pack a whole lot more energy into the same sized or even smaller package. Let's take Toyota's claim. For example, they say an EV equipped with their solid-state battery can go a whopping 750 miles on a single charge. That's right, 750 miles. With that kind of range, suddenly long-distance trips in an electric vehicle aren't just possible. they're downright practical. So say goodbye to range anxiety. That would be a thing of the past. When it comes time to juice up your battery, you'll be pleasantly surprised by just how quickly it could happen. Thanks to those solid electrolytes, these batteries can handle higher voltage tolerances, which translates to faster recharge times. According to Toyota's reports, you could charge up to 70% of the battery's capacity in under 10 minutes. That's almost as fast as filling up your tank at the gas station. And here's the cherry on top. Not only are solid-state batteries a game changer for owners, but they also bring a whole host of improvements to the manufacturing process too. This is because of their potential for rapid and streamlined production. And here's how. While lithium-ion batteries need to be filled with liquid electrolytes before they can get to work, solid-state batteries skip this step entirely. So why does that matter? Well, filling those batteries with liquid electrolytes is a time-consuming process that requires pinpoint precision, and when you're talking about mass production, time equals money. So over time, those traditional lithium-ion batteries end up costing a pretty penny, but solid-state batteries, they sidestep this whole ordeal. With their solid electrolytes, the production process is as simple as pie. Just slap the components together and you're good to go. Plus, since they're simpler to make, they also are simpler to use. And we all know that simplicity is the name of the game when it comes to both production efficiency and real-world functionality. So not only are solid-state batteries safer, more efficient, and longer lasting, they're also easier and cheaper to produce. Another key benefit of solid-state batteries, their potential for a longer lifespan. Because their electrolytes are made from polymers and ceramics, they experience far less chemical degradation compared to their liquid or gel counterparts. And what does that mean for you? Well, it means you can use the battery more extensively before its capacity starts to dwindle. So when you add it all up, solid-state batteries come out on top in just about every way imaginable. But hold on, before we start handing out the gold medals, let's just take a step back. If solid-state batteries are so amazing, then why weren't they the talk of the town 2 centuries ago when they first were proposed? Well, the answer isn't quite as clear-cut as you might think. Despite their ambitious goals, solid-state batteries do have a few notable issues that have kept them from widespread use. The biggest drawback? Their short real-world life expectancy. While they do have the potential to outlast regular batteries, achieving that longevity requires some serious maintenance. Here's the deal. Those solid electrolytes need to be checked regularly and replaced if they start to show signs of significant degradation. If you neglect this upkeep, the solid-state batteries can develop dendrites, little lithium metal structures that like to grow inside the battery. And dendrites are troublemakers. They can cause short circuits, which, while not a major safety hazard, will certainly put a damper on your battery's performance. Furthermore, despite the potential for being simpler and cheaper to manufacture at scale, the truth is that solid-state battery technology has always been too advanced for mass production. This complexity not only drives up costs, but also adds layers of intricacy to the manufacturing process. Additionally, while solid electrolytes may offer cost and simplicity benefits, their manufacturing process remains limited due to being relatively unexplored territory. Crafting them requires precision and expertise. But as we know, Toyota isn't one to shy away from a challenge. They've been hard at work addressing these issues head-on. In fact, Toyota's had its sights set on not just matching regular lithium-ion batteries in terms of lifespan, but surpassing them. According to their announcements, their solid-state battery prototypes are projected to cover over 500,000 miles without any significant loss of capacity, and that's some serious durability. However, reaching this level of performance takes time. Toyota's commitment to perfecting its version of solid-state batteries is why the development process is lengthy. They're leaving no stone unturned in their quest to revolutionize the industry. Despite the current higher production costs, Toyota aims to ramp up production of solid-state batteries to achieve economies of scale, potentially making them similarly priced, if not cheaper than lithium-ion batteries. Toyota's CEO, Koji Sato, recently announced plans to start producing solid-state batteries by 2027. Sato expressed confidence in the current battery iteration, but emphasized the importance of continued testing to iron out any potential flaws. flaws. While the initial solid-state batteries may not match the promised 750-mile range, they're expected to be 10 to 20% better than equivalent lithium-ion batteries, an impressive improvement. The first batch is projected to offer around 500 miles of range, which is still a remarkable feat. However, Toyota won't immediately replace lithium-ion batteries with solid-state ones due to profitability considerations. Instead, they'll offer both options to consumers. Many skeptics have raised concerns about the complexity of mass-producing solid-state batteries, especially within an ecosystem that's been tailored for lithium-ion batteries. Additionally, both solid-state and lithium-based batteries face environmental challenges. Lithium mining, in particular, is notorious for its toxic impact on soil and water. Battery manufacturing and recycling processes also contribute to pollution, and current lithium battery recycling methods aren't efficient or cost-effective enough to be truly sustainable. In response, car manufacturers have been exploring alternative power sources for electric vehicles. Toyota, for example, has dabbled in hydrogen combustion engines, although these are still in the conceptual stage due to hydrogen's reactivity. However, Toyota is renowned for tackling challenges head-on and finding innovative solutions. Recently, they've shifted focus to an entirely new engine type, an ammonia-powered engine, and this engine aims to marry the environmental benefits of electric vehicles and hydrogen engines with the convenience of traditional combustion engines. So, do you think these alternative battery types will work? Let's hear your thoughts in the comment section down below.